Good morning to everyone. Okay. So yesterday we discussed this problem and we found the differential equation. So now I am going to give one more idea, maybe that is very useful for to you. Uh, so to form the differential equation, uh, actually we find the moments. Okay, so moment equal to force into perpendicular distance. Actually here sign is the only okay, sometimes you may be here I put plus, here minus, here I'll put plus. Okay, but I gave one explanation yesterday. The explanation is what I told yesterday is uh, the form the here y is what I told here, p is what, p is the horizontal puller, p is horizontal pull, and y is the perpendicular distance. Okay, so I think you know the right hand thumb rule. Okay, so just I will tell the, just recall you. I think you know better than me the right hand thumb rule. Okay, I will write, just I will write here. This is the force F. So this is the, this is, I will take radius this side. Okay, this is the origin. Okay, so this direction, this is anti-clockwise direction, so positive. And then similarly, if I consider this is a force, this is a radius. Okay, so this is a clockwise direction here, so negative. And this is force, force is downwards here. And here the radius, this is the origin. Here it is clockwise direction, negative, and then force is downwards, and this is the origin. Here we have the radius x, so this is anti-clockwise direction, so positive. So now you should tell here the horizontal pull p and the vertical distance y. So out of 4 diagram, which one is correct, suitable for py?
Third diagram, sir.
Third diagram. Third now, எனக்கு 1 2 3 this one.
Yes, sir.
From the you should take here moment about n, not about origin. I feel that the first diagram, because if you rotate 90-degree clockwise, okay, 90-degree, sorry, anti-clockwise direction, you will get this. Is it correct? நல்லா பிசிக்ஸ் நல்லா படிச்சிருக்கீங்க, எக்ஸாம்லாம் எழுதிருக்கீங்க. மேக்ஸில் எக்ஸாமே இருக்குல்ல, ஆன்சர் பண்ண மாட்டேங்கிறீங்களே. ப்ளீஸ் டெல். This is not mathematics. I am asking, I think it's a basic physics, sir. think so whether my argument is correct or not, I'm asking. Manigandan, Pragadish,
Sir, it will
Aditya.
be
Ah,
force cross. It will be force cross at the perpendicular distance.
yeah, okay. So my problem is sign. Here plus, here
Positives.
minus, yeah, positive. So which one? First
It is
of four,
anti-clockwise.
yeah, anti-clockwise.
Anti-clockwise.
So there are two positive signs. This is also positive, this is also positive. Okay. I'm asking which one? Out of these two, which one? I feel that the first one. Okay. So otherwise, think about it, and then you can tell later. Similarly, you should tell what WL by 2. That is a force. Okay, that is force. That is a downwards. Okay, WL by 2, just the opposite direction. I told that this direction. Okay, and this is opposite to the bending. That's why I told that negative sign. But using thumb rule, you can write easily find the sign. Easily find the sign. So that's why I want to tell this idea to you. So try, and if you and maybe you can post in the group. You can write a little bit better way and then post in the group, and then we will discuss maybe after the exam. So this is the first problem. Okay, I think we got the differential equations here. Uh, and then now, okay, so what is if you simplify this, what you will get? EI into d square y by dx square, d square y by dx square, okay, minus I think plus py, yeah, so minus py, py uh, equal to I will take commonly omega by 2. If I take commonly omega by 2, what is remaining? Omega by 2, if I take commonly remaining x square minus Lx. This is 1. Okay. So now you can throw the divide by EI, d square y by dx square minus p by EI, okay, into y equal to omega by 2 EI into x square minus Lx. Okay, now I will take, this is a square, p by EI equal to a square. So d square y by dx square minus a square y equal to omega by 2 EI, omega by 2 EI into x square minus Lx. Okay. So instead of EI, I can write uh, actually omega 1 by EI. Yeah, 1 by EI is what? P square by A. 1 by E is A square by P. Okay, A square by P. Already omega is here. A square by 2 is here. 2 into P. So, so please check it. This is the reason. Now I call this is equation is 2. So this is the differential equation of the elastic curve. This is the differential equation of the elastic flux. Okay, so now the auxiliary equation is m square minus, okay, uh, m square minus a square is equal to 0. So you should write this is t square minus a square into y equal to right hand side function. So m square minus a square equal to 0, m square equal to a square, m equal to plus or minus a. So the complementary function is equal to c1 into e power ax plus c2 into e power minus ax, ei equal to 1 by d square minus a square. So 1 by d square minus this. Right hand side is what? Omega a square by 2p into x square minus l. So this is the right hand side function. So from this we have uh, omega a square by 2p omega a square by 2p into I will take minus a square commonly. So then you get 1 minus d square by a square here into x square minus lx. So a square gets cancelled minus omega by 2p into 1 minus d square by a square whole power minus 1, okay, into x square minus lx. So which is equal to minus omega by 2p into 1 plus d square by a square is enough. I don't need the next term, x square minus lx. This is equal to minus omega by 2p into 1 into x square minus lx, x square minus lx, and then if you differentiate it twice, you have 2, this is 0. So 1 by a square into 2. So now our this is a ti. Now the general solution y is equal to c1 into e power ax plus c2 into e power minus ax, take minus commonly, plus omega by 2p into lx minus x square minus 2 by a square. So I call this is equation is 3. So now we need to find the value of C1 and C2 using the boundary conditions. So here the two ends are here, it is freely pinned. Okay, freely pinned. So I think you have the, you know the boundary condition. Since horizontal tie rod is freely pinned at each end, what is the boundary condition? Can you tell at
y equal to 0, d
y equal
square
to
y by dx square equal to 0.
y equal to 0 and the second derivative equal to 0. Correct, Lakshmanarayanan? Y equal to 0 at x is equal to 0. Okay, So now I'm first I take only y equal to 0. Second derivative I'm not going to use now because now I have y. Okay. So okay. So at both the end, at the both end, that is O or origin and L, we have y0, second derivative 0. Similarly, at L, y0, second derivative 0. Yeah. So now I am going to, okay, first I will write, this is at the origin, at the origin. Similarly, and y equal to 0, at the x is equal to L. At y equal to 0, at the x is equal to L. This is at the capital A. This is the point here. Capital, here this is O, origin. Okay, now I am going to use the first condition in equation 3. In equation 3, I am going to use the first condition. So then you will get, please check it, 0 equal to, so C1 plus C2, this is 0, this is 0, 2 gets cancelled, minus omega by Ps square, Ps square. C1 plus C2 minus omega by Ps square. So this implies C1 plus C2 equal to omega by Ps square. This is equation 4. So up to this, I think this should have got it. Is it correct? Up to this equation. This is
Yes.
okay. Similarly, okay. So similarly, you can get y equal to 0 at x is equal to L. So if you apply this condition, y equal to 0 at x is equal to L, here in this equation, in equation 3, okay, so I am going to write here y equal to 0 at x is equal to L. So 0 equal to C1 into e power AL plus C2 into e power minus AL minus L square minus L square is 0. Okay, so minus 2 gets cancelled, minus omega by Ps square. Omega by Ps square. Okay, so from this we have C1 e power AL plus C2 e power minus AL equal to omega by Ps square. We call this is equation 5. So now from these two equations, we will try to find the C1 and the C2. So multiply the first equation, or sorry, fourth equation by e power AL. So we'll get C1 into e power AL plus C2 into e power AL equal to omega by P square into e power AL. And take fifth equation as it is. So C1 into e power AL plus C2 into e power minus AL equal to omega by P square. Okay, now if you subtract it, minus, 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 okay, I think this is gets cancelled. Here, I think you can take C2 commonly, so C2 into e power AL, e power AL minus e power minus AL. This is the left hand side equal to omega by P square is common. Yes, omega by P square is common. Remaining you have e power AL minus 1. E power AL minus 1. Okay, I will rewrite this last step again. So C2 into e power AL minus e power minus AL, which is equal to omega by P square into e power AL minus 1. Now from this C2 equal to omega by P square to e power AL minus 1 divided by e power AL minus e power minus AL. So now I am going to simplify this one. So omega by P square e power AL minus 1. So we can write e power minus AL is 1 by e power AL, and then if you take LCM, you will get e power 2AL minus 1 divided by e power AL. Otherwise, I will multiply by e power AL here. So this is actually the denominator is in the form of a square minus b square. That is e power AL whole square minus 1 square. So omega by p square into e power AL minus 1. A square minus b square is a plus b into a minus b. E power AL minus 1 into e power AL plus 1 into e power AL. So you can cancel these two terms. Finally, you'll get C2 equal to omega by P square e power AL by e power AL plus 1. So this is C2. Now C1. C1 from the equation 4. So what is equation 4? Okay, 4 C2 implies omega by P square minus C1. C1 is omega by P square into e power AL by e power AL plus 1. So you take commonly omega by P square. So remaining 1 minus e power AL by e power AL plus 1. So which is equal to omega by P square. So take LCM e power AL plus 1. So e power AL plus 1 minus e power AL by e power AL plus 1. So you can cancel these two. So C2 equal to okay omega by P square 1 by e power AL plus 1. This is C2. So we got the C1 and the C2. Now I am going to substitute the values of C1 and the C2. I think equation number 2. Yeah, 3. Equation number 3. I'm going to substitute the C1, C2 here. So please check carefully whether I am writing correctly. Equation 3 implies y of x is equal to C1. C1 is omega by P square into 1 by e power AL plus 1. This is C1. This is looking like C2. It is a C1. C1 is omega by P square. Okay. What is here? You have C2. You have e power AL. Okay. So that is only difference. Okay. Into e power AX plus C2. C2 is omega by P square into 1 by e power AL plus 1. I think I am doing some mistake.
Sir,
Sir,
what we
this is
found
C1,
finally is
sir.
C1, sir.
Sorry.
Sir, what we found with the equation, substituting the equation for C1, sir.
This is
C1,
C1 now.
yes.
Oh, this is C1. Okay, so this is C1. So sorry, this is C1. C2. C2 is omega by P square e power, yeah, e power AL by e power AL plus 1 into e power minus AX. I think now it is correct. Plus omega by 2P into Lx minus x square minus 2 by a square. So I call this is equation 6. Yeah, 6. Okay. So up to this is okay. Now the question is they are asking the central deflection. The first question is central deflection. So how to find the central deflection? Anybody? The central deflection is y at where?
X equal to L by 2.
Very good, Parasuran. X is equal to L by 2. Okay. So substitute in 6. So if x is equal to L by 2 in 6, it is y at the central, that is x is equal to L by 2, which is equal to uh, omega by okay, P square. I will take omega by P square commonly. Here also we have, here also we have. Okay, and e power AL plus 1 is also common. So I will take e power AL plus 1 is also common. Remaining you have e power AX. So e power AX is equal to L by 2 and plus e power AL e power AL into e power minus A x is equal to L by 2. So this minus AL by 2. Okay, and plus omega by 2p into x is equal to L by 2 means L square by 4. Okay, L square by, sorry, L square by 2, L square by 2 minus L square by 4 minus 2 by A square. Okay, so this is nothing but what? E power AL by 2. So here also e power AL by 2. So 2 times e power AL by 2. So the next page I will write. So 2 times omega e power AL by 2 divided by P square into e power AL plus 1. Okay, plus omega by 2p into this is L square by 4 minus 2a square. So this is actually y at x is equal to L by 2. So okay, central deflection is over. One more thing, they are asking the question, what is central deflection? We got it. Next, we should find the maximum bending moment. So, okay, please tell how to calculate the maximum bending moment.
Real d squared y by dx.
Okay. So you should take a derivative. Okay, okay, dy by dx. But here there is one more option. is here because if you take a derivative for y, this one, I think this one equation 6, and you should equal to 0, okay, and then you should find the second derivative. So it will take time, okay, va? So here there is one more option. Anybody know how to find the maximum bending moment without you finding the derivatives?
We could substitute equation 6 in equation 1. After
Uh,
that, substituting x equal to L.
மணிகண்டன் கொஞ்சம் கரெக்டாக சொல்கிற மாதிரி தெரியுது, ஆனால் கொஞ்சம் கிளியராக எனக்கு புரியுற மாதிரி சொல்லுங்க.
In the sixth equation, we could substitute the sixth equation in first equation.
Very good,
Starting
very good, very good, very good.
and substitute x equal to L.
Yeah, correct. So first equation வந்துட்டு இந்த equation, ஓகேவா? So instead of choosing the first equation, you can choose the, yeah, it is better to choose the first equation. So first equation எடுத்துக்கலாம், because we know that the bending moment is ei into d square y by dx square, okay? So that is the definition I gave in the first class. That is equal to py plus this quantity. So now, as Manikandan told, should substitute uh, uh, the maximum bending moment is at the x is equal to L by 2. So y at the L by 2. Very good. So now a little bit I'll write here. Please check it whether I am writing correctly. Okay. So what is equation 1? So first I will write the sorry, the bending moment. The bending moment is maximum bending moment is maximum at the point of maximum deflection. The point of maximum deflection. Okay. So maximum deflection is at x is equal to L by 2. So therefore, the maximum bending moment is equal to ei into d square y by dx square at x is equal to L by 2. So we know that from the first equation ei into d square y by dx square equal to py minus py plus omega by 2, please check it, omega by 2 into x square minus lx, okay, lx. Okay, now by this is actually by equation 1. So now you should find y at x is equal to L by 2, is equal to L by 2, and here also you should substitute x is equal to what? L by 2. Okay, so I write x square. So it is better to write in the next step. You should write x is equal to L by 2. So for clarity, I am writing this term. Okay, this is equal to p into y, x is equal to L by 2 plus omega by 2, x square is L square by 4 minus L square by 2. So now y at x is equal to L by 2. You should write everything. You should multiply by p. So here also you have p, here also you have p. So p gets cancelled. So remaining you should write these two terms without this p. I will write in the next page, which is equal to, so we get 2 omega into e power al by 2 divided by a square into e power al plus 1, okay, plus omega by 2 into L square by 4 minus 2 by A square, okay, and then finally last term plus omega by 2. Is it possible to simplify? Yes, you can simplify. You simplify this, you get what? This is minus L square by 4. So if you multiply, minus omega L square by 8. Minus omega L square by 8. So this is the final answer. Okay. So the next problem is this problem. Okay. Now here the cantilever. So what is time now? A cantilever beam of length L and weighing omega pounds per unit is subjected to a horizontal compressive force capital P at the free end. At the free end, taking the origin at the free end, okay, taking the origin at the free end, and the y-axis is upwards. Y-axis is upwards. Establish the differential equation of the beam and hence find the maximum deflection. So originally the beam is the dotted line. So this end is fixed. So at A. So due to the compressive force, it is coming like this. The beam is now like this curve. Okay. So now you should. This is a free end. You should take this is origin. You should take this is the origin. And here I am taking the point on the bending beam. This bending beam I am taking n of x comma y. So and hence this is length x. From the origin to here it is x. From here to here it is y. Okay. So the deflection is delta. Is a small. Okay. From here to here I will take y equal to delta. Okay. Now the external force acting to the left of the section n dash is, first one is the compressive force capital P. Second one is the weight of the portion ON equal to omega x, weight of the portion ON, weight of the portion ON, okay, equal to omega x. Why it is omega x? So the length is x, okay. Omega is unit per, it is given, pounds, okay, LB per units. So total weight is omega x. So the weight of the portion OX is equal to WX acting at the midpoint. Midpoint is x by 2. Point is x by 2, and there is no restoring force. In the previous problem, we have the restoring force at the both end, because in the previous problem we have both ends are freely pinned, but here one side is clamped, the other side is free. So that's why we don't have the restoring force. So now I am again I am going to draw the same diagram, okay, using that thumb rule. So I think now you will tell because here you have P into Y. You can see here, this force is P and perpendicular distance is Y. The question is why negative sign? Similarly, omega x is a force. Perpendicular distance is x by 2. Why it is minus? So, to find whether it is a positive or negative, you should know the uh, thumb rule. So here I will draw the diagram quickly again. So you should tell which one is the correct diagram for compressive force and omega x, right of the portion. This is a positive. Here you are taking moments about n. Moments about n, but I will take origin here. But you should consider n only here. Now here, this is F, this is X, this is anti-clockwise direction. So this is anti-clockwise direction, negative sign. And then third diagram, this is 1, 2, third one is F, X, origin. This is clockwise, so negative, and then force. This is a radius. This is origin. This is anti-clockwise direction, positive. So first one, compressive force for P and Y. Okay, P and Y. Which diagram is a correct one out of 4? Anybody? Aditya?
So the second one.
Second one. Okay. So why it's second one? Can you give the reason?
Because of the clockwise direction.
Clockwise direction. Okay. So otherwise I can tell if you rotate this is 90 degree, you will get this diagram. Is it correct?
Yes.
This, yeah. Okay. If you rotate 90 degree, F will come this side, X will come this side. Okay. So this is correct one. So that's why negative, that is the reason I put in here negative sign. And then for right of the portion OX equal to, why it is negative sign? Actually omega x into x by 2 because of midway, that's why multiplied by x by 2. Why here it is negative sign? Diagram, second diagram or fourth diagram? Pragadish?
Sir, for this fourth one, sir.
Four, this one.
Sir, third one, sir. The left
Third
side.
one,
Left
yeah.
side. Yes, sir.
For this third one, because force is downwards. Okay, force is downwards. So that's why we should choose the third diagram. That's here you have a negative sign. So that is why here you have minus omega x into x by 2. Okay. So now the remaining part, okay, I will try to do it quickly as early because I need to finish it before 12:30 because we have the class at 1 o'clock. At least half an hour I need to give for lunch to you. I think somebody now taking the lunch. I think Aditya, lunch over?
No, sir. No, sir.
No. Okay, thank you. Last time you finished the breakfast. That's why I'm asking. Okay. So ei into d square y by dx square plus py equal to minus omega x square by 2. Okay. So, okay. So I will write quickly the next page. Pi into d square y by dx square, okay, plus py equal to minus omega x square by 2. Okay, now throw out divide by ei. So if you throw out divide by ei, you get d square y by dx square plus p by ei into y equal to minus omega by ei into x square by 2. So I will take this is n square, p by ei equal to n square. So we have d square y by dx square plus n square into y, which is equal to uh, 1 by ei equal to n square. So minus omega n square by 2p. So please check it into x square. The reason is, this is the reason. So now d square plus n square into y equal to minus omega into n square by 2p into x square. I call this is 1, equation 1. So auxiliary equation is m square plus n square equal to 0. So this implies m equal to plus or minus in. So complementary function equal to c1 into cos nx plus c2 into sin nx. So I got c1 and cf. Now particular integral. So 1 by d square plus a square into right hand side is minus omega n square by 2p into x square. So x square is algebraic, so type 3. So minus omega by omega n square by 2p is a constant. 1 by n a square into a square, n square. Here I write n square, here I write a square, n square. This is n square. So here we have n square into 1 plus d square by n square, so into x square. So from this we can write minus omega by, I think cancel n square, minus omega by 2p into 1 plus d square by n square whole power minus 1 into x square. So now expand it. So minus omega by 2p 1 minus d square by n, d square by n square into x square. So this is equal to minus omega by 2p into x square minus 2 by n square. So this is your PA. So final answer y equal to c1 into cos nx plus c2 into sin nx. I will take minus commonly. So omega by 2p into 2 by n square minus x square. 2 by n square minus x square. So I call this is equation number 2. Okay, but one end is a clamp, the other end is free. So first I will use the condition on the clamped end, because free end, you know that y double dash and y triple dash are 0. So now I have only y. So that's why I am going to use the end x is equal to L. At x is equal to, if suppose the end is clamped, then what is the boundary condition? Can you tell anybody?
Y equal to 0, y dash equal to 0.
Y equal to 0, y dash equal to 0. Okay, yes, correct. Okay, now you can tell. Now you can tell, since the end is correct for this, since the end x is equal to L is clamped at a height of delta from the origin So I think you can see in the diagram delta from the origin. I already I told that after the deflection, there is a here you have see it is a delta. Originally this position, now you have in this position. Sorry, delta from the origin, comma the boundary conditions are the boundary conditions are the following. So now I am expecting answer from you. Then I think you know the answer. When x is equal to L, what you have?
Maximum deflection.
Sorry.
Maximum
Yeah,
deflections.
yeah. What is the deflection? Yeah, you are right. Parasol is correct. What is the deflection? Delta. Okay. So in the diagram I showed that when x is equal to L, y equal to delta, and dy by dx equal to 0. Okay. So now I am going to use when x is equal to L, y equal to delta first. After differentiating this equation 2, I will use when x is equal to L, dy by dx equal to 0. So now I am going to use when x is equal to L, y equal to delta in equation 2. So 2 implies delta equal to C1 into cos NL plus C2 into sin NL plus omega by 2p into 2 by m square minus l square. I call this is equation A. Now differentiate equation 2 differentiate equation 2 with respect to x. So you'll get dy by dx equal to, so please check it. I'll write the answer, you can check it. Minus C1 into sin nx plus C2 into n into cos nx minus omega x by t. So I call this is equation 3. Now I am going to use the other condition. When x is equal to L, dy by dx is equal to 0. So 0 equal to minus C1 n sin nl plus C2n cos nl minus omega L by T. We call this is 4. Okay. Now I am going to use the boundary condition on free end. So the free end, second derivative equal to 0. So that's why I am going to differentiate equation 3 with respect to x. So you get d square y by dx square equal to minus c1 into n square into sin nx, sorry, cos nx minus c2 into n square into sin nx minus omega by p. So this is 5. Okay, at the free end O, next line, the free end with origin O, there is no bending moment. There is no bending moment. That is when x is equal to 0, that is origin, a second derivative equal to 0 and the third derivative equal to 0. So now I am going to use only second derivative equal to 0. So if we use second derivative equal to 0, when x is equal to 0, you have 0 minus c1 n square, this is 0 minus omega by p. So equation 5 implies 0 equal to minus c1 into n square minus omega by p. So this implies c1 n square equal to minus omega by p. I need c1 minus omega by p n square. I got c1. Now I need to find the c2. So I'm going to substitute the value of c1 in equation 4. If you substitute in equation 4 the value of c1, you can get the value of c2. So equation 4 implies, so please check it carefully. Here you have minus, here also you have minus c1, so plus omega by p n square into n into sin nl plus c2 into n into cos nl minus omega L by p. Okay, left hand side is 0, I think so. Okay, so this is 0. Equation 4 implies. So I will take like this. Now from this write the terms which contain C2 one side, the remaining terms the other side. So C2 n cos nl equal to omega L by p minus omega by pn into sin nl. So I need only C2 omega L by pn. 1 by cos nl is secant nl minus omega by p n square. Sin by cos is tan. So this is your C2. Okay. So now the question they are asking what? They are asking we need to find the maximum deflection. Okay, maximum deflection. So the question is now whether we need to substitute the value of C1, C2 which equation, either 2 or some other equation, or you tell how to find the maximum deflection. I think we need to find the maximum deflection. How to find the maximum deflection? Okay, so just I will tell you because time is not only 12:30. So you need to substitute. It is better to substitute C1, C2 in equation A. Okay, because here you substitute what? Barasaran told that when x is equal to L, y is a maximum deflection. So the maximum deflection is delta. So the question is also they're asking here what? The question is also it is asking maximum deflection. So that's the reason I am substituting. Then otherwise you need to substitute C1 and C2 in equation 2, and then again when x is equal to L, y equal to delta. So you should proceed like this. Okay, or otherwise directly you can substitute in equation A. So that's why I am substituting in equation A. Substitute C1 and C2 in A. So delta equal to minus omega by Pn square into cos Nl. This is actually C1. This is actually C1. C1 into cos Nl plus C2. C2 is what? Omega L by Pn into secant Nl minus omega by Pn square into tan Nl. This is a C2 into sin Nl plus omega by 2p into 2 by n square minus L square. Now, okay, multiply by sin Nl, okay, and then group it. So minus omega by Pn square is common. Here you have cos Nl. Here you have sin square Nl by cos Nl. And then plus this term omega L by Pn into secant Nl multiply by omega by 2p plus omega by 2 gets cancelled, Pn square minus omega L square by 2p. Omega L square by 2p. So this is nothing but cos square, sin square theta plus cos square theta is 1. 1 by cos theta, that is a secant theta. So minus omega by Pn square into secant theta, secant Nl plus omega by Pn into tan Nl by Pn into tan Nl. Okay, plus omega by Pn square minus omega L square by 2p. So from this I am taking commonly omega by Pn square. So remaining is 1 minus, from this I took omega by P. So minus L square n square by 2. From this I will minus secant Nl. Here you have plus L N because I took n square commonly, here have n, so ln p I took commonly, okay, into tan n. So this is the maximum deflection. The problem is over. So in the next problem, just I am going to discuss with you only the differential equation. So once you form the differential equation, remaining part you can try. I think Pragadish will try. There are Pragadish, are you ready?
Yes, sir.
Okay. So because uh, okay. So now this is the loop. Okay. In the first loop, you can see the direction of the current is going this way. So first consider only this loop. So what is the equation, differential equation you will get in this loop? Forgot the second one.
I or L D
I
square.
I1 I2 into R. Okay,
Yes, sir. I2
I2
or
plus
plus L
uh,
D square I1 divided by dt square.
R d I1 by
Yes, sir. D I1 by dt
T equal to
equal to E.
E of T. E of T or E. Okay, so first equation you got it. So anybody try to tell the second equation in this loop? It is open to everybody.
I2R plus
I2R plus
plus di3 by dt by into 1
uh,
by c equal to E
di3
by
di3
dt
dt
into 1 by c equal to E.
okay partial Lakshminarayana or sorry
Yes, sir.
Lakshminarayana okay கொஞ்சம் I think there is some mistakes இருக்கு என்ன mistake இருக்கு there is I think this is correct I2R is correct there is some problem here so actually anybody want to try I will wait for you so, if you tell the answer then I will be happy that's why I'm expecting answer from your side otherwise I will tell finally
Sir, can we write Q3 by C, sir?
Karthikeyan very good I2 R okay Q3 by C okay but here what is sign
Minus.
Sign minus.
minus because if you
The
consider
current is leaving.
yeah in this direction I3 is opposite okay so minus Q3 by C equal to 0 okay now if you differentiate this equation we'll get di2 by dt into R minus dq3 by dt into 1 by c equal to 0. Throughout multiply by c, we get rc into di2 by dt minus dq3 by dt is I3. Okay, because you know that I equal to dq by dt. So this is I3 equal to 0. But here I1 equal to what? I2 plus I3. So we know that the current I1 is filtered in this node I2 plus I3. So instead of I3 you can rewrite, I will write here RC into di2 by dt minus of I3 is what? I1 minus I2. I1 minus I2 equal to 0. Okay, so first equation is this, second equation is I will write here RC into di2 by dt okay plus I2 minus I1 equal to 0. So this is the second equation. Now the problem is, it is given the problem. Here it is given. E, L, R, C, it is given. So the solution is also directly I gave a solution. Okay. So actually they solved using Laplace transform. That is, this is actually I took the problem from the third semester book. The book which I think I sent you Blind James from the not Blind James, Zill book. Zill book, from the topic Laplace transform, I took this problem. So they done it using Laplace. Maybe you studied third semester, but now you should use what you know the simultaneous equation. You know how to solve the simultaneous equation. So try to get this answer, and also finally you get this one. So this is the idea. Okay. Now the next problem. What is the this? Just I gave the circuit. What is the equation? This is the last problem. சாப்பிட போறீங்களா? யாருமே ரிப்ளை பண்ணல.
L into
L into
d square q by dt square.
Okay, I want current I.
di by dt
Ah,
plus ri
Ri
plus q by c
Q by C. Very good.
is equal to e of t.
Sorry. Adityava.
Yes, sir.
Okay. Instead of Q, you can write in terms of I. You can write how? How you can write in terms of I? Is it correct, Aditya? Because we know that
Yes,
I
sir.
equal to what? dq by dt.
dq by dt
Okay, wow. So for Q equal to what? Integral I.
I dt.
So I think it is available in this book. So they gave the circuit, they gave the equations here. Okay, wow. And first already I explained this one. Using Laplace transform, they find it. So one more diagram I gave. Okay, in the same book. Okay, Zill book. Okay, maybe I will show you that also. Oh yeah, here. Okay, series circuit. And maybe today I will send this book to you. I think Grewal book is with you or not? Grewal.
Yes, sir.
Whether I shared the book, otherwise already I shared the book in the group. Okay, I don't know. Otherwise, I will share the book. So try to solve in bending of beam. Some of the problems are here. So try to solve those problems. So and similarly for electric circuit, some of the problems are here. So practice those problems. Okay, thank you. I will just send the problem, send the book. Try to solve exercise problem. Maximum example problems we solve. Try to solve not all the exercise problems, one or two problems. Okay, thank you. If you have any doubt, you can ask to me. Otherwise, meet next week. When your exam will finish?
Wednesday, sir.
Wednesday, sir.
Wednesday. Wednesday at what time?
3:30.
3:30. So Thursday onwards, we have class. Okay, thank you. Bye. All the best for everyone.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you. Raghuvesh Sulba.
Sir, for the bending of beam, will the diagrams be provided in the question, sir?
Diagram சொல்லிட்டு புரியல.
Sir, question diagram கொடுத்திருப்பாங்க.
கொடுக்க மாட்டாங்க. டயக்ராம் கொடுக்க மாட்டாங்க. யூஸ்வலாக கொடுக்க மாட்டாங்க. ரேராக தான் கொடுப்பாங்க. நம்ம தான் வந்துட்டு we should understand the question and then we should draw. So that's why I will send the book to you, Grewal book. I will share to you. So try to solve more problems from bending of beam and electric circuit. Okay, bending of beam, electric circuit, and Newton's law of cooling, and then growth and decay. So this is the application part. And then you'll go study the remaining part, whatever it is, Euler or variation of parameter. Okay, so remaining part. First you finish application part, and then you go to uh, remaining sections. So that is my suggestion. Yes. Okay. Any other doubts?
சார் ஆனா லாஸ்ட் கொஸ்டின்லாம் டெல்டா ஹைட்ல வந்து சஸ்பெண்ட் ஆயிருக்குன்னு கொடுக்கல சார் கொஸ்டின்.
கொடுத்துருக்காங்க. டெல்டான்னு கொடுக்கல. ஓகேவா? ஓகேவா? yeah, cantilever beam of length L, but என்ன கொடுத்துருக்காங்க, taking the origin at the free end and y axis upwards. ஓகேவா?
ஓகே சார்.
ஓகேவா? ஸோ அதுலேயே தான் நம்ம எழுதணும், வேற வழி இல்லை.
ஓகே சார்.
ஓகேவா? பட் என்னை பொறுத்த வரைக்கும் they will give the differential equation. Okay, so for safety purpose I gave the problem like this, how to form the differential equation, but maximum they will give the differential. Okay, thank you.
Yes sir. Thank you sir.
Any other doubts? Okay, thank you everyone.
Thank you, sir.
Thank you.
Sir.
சொல்லுப்பா
சார். சிங்குலர் சொல்யூஷன் ஒரு சம்ல p ஸ்கொயர் + 1 = 0ன்னு வருது சார். சார் நம்ம இக்னோர் பண்ணிரோம் சார்.
இல்ல அது p ஸ்கொயர் மைனஸ் அது வந்துட்டு அது ஆக்சுவலா டிவைட் பண்ண கூடாது. அது ரெண்டு இடத்துலயுமே p ஸ்கொயர் மைனஸ் 1 வரும். லெஃப்ட் ஹேண்ட் சைடுலயும் வரும் p ஸ்கொயர் மைனஸ் 1, ரைட் ஹேண்ட் சைடுலயும் வரும். கரெக்ட்டா?
சார் இல்ல சார், p ஸ்கொயர் + 1 வருது சார். அது p ஸ்கொயர் +
இக்னோர் பண்ண கூடாது
சார். அது இக்னோர் பண்றாங்க சார் ஒரு சம்ல. ஈக்குவேஷன் சால்வபிள் ஃபார் y லயோ p லயோ சார்.
நம்ம பண்ணிருக்கோமா?
இல்ல சார், புக்ல ஒரு சம் பார்த்தேன் சார்.
புக்ல பண்ணிருக்காங்க, நானும் பார்த்திருக்கேன். பட் we don't ignore that one. ஓகேவா?
ஓகே சார்.
அது from that you can get the singular solution.
சார் p = i ன்னு வந்துருமே சார் அப்படி போட்டா?
இல்ல p ங்கிறது dy/dx தானே?
எஸ் சார், dy/dx = i வந்துரும்ல சார்?
இல்லையே. p ஸ்கொயர் = என்ன வரும் உங்களுக்கு?
-1. p ஸ்கொயர் = -1 சார்.
p ஸ்கொயர் -1னா இப்ப dy/dx ஹோல் ஸ்கொயர் -1னா எனக்கு அந்த
dy. எஸ் சார்.
ஒரு பக்கம் கிராஸ் மல்டிப்ளை பண்ணிக்கோ. ஸோ dy = dx வருமா?
சார் இல்ல சார், dy/dx ஹோல் ஸ்கொயர் = -1 சார். dy/dx √(-1).
புக்ல இருக்கா? நான் செக் பண்ணிட்டு சொல்றேன். சரியா?
ஓகே சார். ஓகே சார்.
நான் பார்க்குறேன். தேங்க்யூ.
தேங்க்யூ சார்.